Okay. And so, six. Okay. Next one. So composite primary key. So what is this is if combination of columns declared primary key, then it is called composite primary key. Okay. So why we declare combination as primary key? So in some tables, we may not uniquely identify by using single column. Actually, why you take primary key? You take primary key to uniquely identify. But in some tables, we cannot uniquely identify by using single column. We need combination of columns to uniquely identify. If combination of columns uniquely identifies, that combination should be declared what? Primary key. So that is called composite primary key. So in composite primary key, combination should not be duplicate. Okay. Then, then, for example, just 1 second. Suppose you take, for example, so there is a table, student table, student ID, student name, student ID 1, name is A, B. So in this table, what is primary key? Student ID. There is a table, course table. In course table, course ID, course name, 10. So suppose, for example, Java, 11, Oracle. In course table, what is primary keys? Course ID. In student table, student ID is primary key. In course table, course ID is primary key. So what is the relationship between these two tables? What is the relationship between these two tables? What is the relationship? One to many now, one to one now, many to many now. What is the relationship between these two tables is many to many, many to many. One student can join for many courses. One course can be taken by many students. One student can register for many courses. One course can be taken by many students. What is the relationship between student and course? Many to many. So tell me how to establish many to many relationship between these two tables. What is it? That you have to remember. One is three rules. I given three rules. What are the three rules? If it is one to one, to establish the relationship, add foreign key to any table. One to many, to establish the relationship, add foreign key to many side table. Add foreign key to many side table. If the relationship is many to many, then create third table. So, like, let's see. I create third table. What the third table is? Registrations table. In this table, I want to store which student registered for which course. In this table, I want to store, this is for to maintain the relationship. Third table is to maintain the relationship. In this table, I want to store which student registered for which course. So then take primary keys of what? Both the tables. Then one is student ID, another one, what's it? Course ID, date of registration, student ID, course ID. Then if you want any extra fields, so when student is registered, date, and what is the fee paid by the student. Okay. Student 1 joined for course 10. Student 1 joined for course 10. So and so date, so and so fee. The same student can join for another course. The same student can join for another course. Yes. Student 1 joined for course 11. So and so date, so and so fee. And the student 2 joined for course 10. So and so date, so and so fee. The student 1 joined for course 10 and 11, and the student 2 joined for course 10. Okay. So this is the table. Suppose in this table, what is primary keys? So can we take student ID as primary key? Can we take student ID as primary key? No, because student ID contains what? Duplicates. So this column contains duplicates. You cannot take this as primary key. Can we take course ID as primary key? No, this contains duplicates. Can we take fee? No. Can we take date? No, because number of students can join on same date. So in this table, no column can be taken as what? Primary key. But when not possible by using single column, then try with combination. In this table, it is not possible to uniquely identify by using single column. When not possible by using single column, then try combination. So tell me, this combination uniquely identifies this combination uniquely identifies a or no? This combination. If I say 110, how many are selected? 1. If I say 111, how many are selected? 1. If I say 210, how many are selected? 1. So this combination uniquely identifies yes. So this combination should be taken as what? Primary key. So in this table, so student ID is not uniquely identifying, course ID is not uniquely identifying, combination is uniquely identifying. So then declare this combination as what, sir? Primary key. Then what this is called? This is called what? Composite primary key. So this is in this table, student ID is primary key. In this table, course ID is primary key. In this table, combination is primary key. Okay, then. Now, okay, then now. Now, now create these tables. Okay, create one by one table. Then, so write create table commands. Now, let's see. Create table what? First one, student ID, member 2. In student table, student ID is what? Primary key. So declare primary key, student name, varchar 210. This is what? Not null. Next one. Insert one or two rows into this table. Insert into student values, student 1 A. Next to, and student 2 B. Okay. Student 1 A, student 2 B. Next one. Create course table. Create table course. Course ID number 2. This is what? Primary key. Course name varchar 210. This is not null. So semicolon. Next one. Then next, insert one or two rows. Insert into course values. Course is 10. Name is suppose some course Java. Next, course 11. Course 11. Then suppose what? Oracle. Okay. Then so one student table is created with two rows. Course table is created with two rows. Next what? Then to maintain the relationship between student and course, create what? Thought table, registrations table. Then create table registrations. Create table registrations. Then in this table, one field is what? One field is student ID. One field is student ID. In registrations variable, SID. SID is what? Number two. SID is number two. Any rule is there for student ID? What is student ID? Student ID is what? Student ID is not primary key. Student ID, course ID combination is primary key. This is not primary key. This is not primary key. Combination is primary key. So what is student ID? See here, the student ID should match with student table student ID. The student ID should be a valid student ID. Whatever the student IDs you enter here, the student ID should be a valid student ID. So the student ID should match with student table student ID. Then what consent you declare? Foreign key. So a column value should match with another table primary key. If any column value should match with another table primary key means it should be declared as foreign key. Then declare student ID as foreign key. How to declare foreign key? By using what? References. Which table? Student table, student ID. Understood? Then. So this student ID is what, sir? Foreign key. This foreign key references this primary key. Next one. Course ID. Course ID number two. And this course ID should match with what? This course ID. This course ID should be a valid course ID. That's all. Where are the valid course IDs are there? Course table. So this course ID should match with course table course ID. Then declare foreign key. Then what? How to declare? References course table course ID. Okay. So in this table, how many foreign keys are there? Two foreign keys. A table can contain number of foreign keys. A table can contain number of uniques, number of not nulls, number of check and sign, but primary key can be only one. Okay, na? Foreign keys can be many, uniques can be many, not null can be many, check and sign can be many, but primary key can be only one. Then, see this here. What is the next one? Date of registration. Next one, fee paid by the student, number 5. Fee paid by the student, number 5. Next one, after this, in this table, what is primary key? In this table, what is primary key? Primary key is combination, this combination. Okay, na? Individual columns are foreign keys, but what is primary key is combination is primary key. So declare this combination as what? Primary key. Primary key, then. So this cannot be declared at column level because it is for single column or multiple. Multiple. You cannot declare at column level. Compulsory it should be declared at what? Table level. Then primary key in bracket SID comma CID. That's all. So what is this is called? This is called composite primary key because you declared primary key for combination of column, then it is called composite primary key. Okay, then suppose let me create these tables. Let me create the tables. So then once again, drop table what? Student. If tables are already there, I'm dropping the tables. If tables are already there, I'm dropping. Then now create the tables. So like student table is created. the two rows are inserted. Course table is created, the two rows are inserted, and we created the registration table. Okay, then that's okay. You know, then okay. Okay, now then okay, now 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 okay. Now now let us what let us test. I want to test composite primary key. How to test? You want to test? How to test? Insert. Insert the data. You want to check the consign. Insert the data. Check whether it is accepting or not. Then what? Let's see. Insert into registrations values. Student 1, course 10. Date is student ID. Student first column. Student ID 1. Course is 10. Date is his date. Fee paid by the student is 2000. Then allowed or not allowed? Huh? Student 1, course is 10. Date is his date. Fee paid by the student is 2000. Then allowed or not allowed? So execute this query. Then one row created. Next one. Student 1 joined for course 11. Student 1 joined for course 11. Allowed or not allowed? Allowed. Student 2 joined for course 10. Allowed or not? Student 2 joined for course 10. Allowed or not? Allowed. This is also allowed. Student 1 course 10. Student 1 course 10. Not allowed. Because this combination is already there. You are trying to insert duplicate. This is duplicate. This is not duplicate. This is not duplicate. This is duplicate. You are trying to insert the duplicate. What this gives? This gives what's that? Error. So what it says, unique constraint is what? Violated. Because you are trying to insert the duplicate. Then when combination is declared primary key, combination should not be duplicate. Okay. So this combination is already there. You're trying to insert duplicate. This is not allowed. So what this gives? Error. Now. Then. So insert. 111, 210, 110. What this command gives? This command gives what's that? Error. Okay, then. Okay, then. Okay, then. And maximum you come across composite primary key when you are establishing many-to-many relationship. 99% you come across composite primary key when establishing what? Many-to-many relationship. Okay. If you want, you try this example. You try this one. Suppose, then once again, just see. The table is orders table. In this table, order ID, order date, delivery date. Okay, na? Order ID, order date, delivery date, customer ID. Then which customer is ordered? Next one. Customer orders for what? Products. You order for product ID, product name, product price, product brand, category, like something like this, category, etc. Okay, then. So now, what is the relationship between orders and products? Order is 1000, 1001, 1002. This is orders. These orders placed by different customers. This is placed by customer 1. This is placed by customer 1, 2, 3. And products, there is a product 100. There is a product 101. There is a product 102. Like that number of products are there. What is the relationship between orders and products? Okay. One order. You place order to buy one product or multiple products. In one order, you can buy multiple products. one product can be purchased in multiple orders. Multiple orders can buy one product. Yes or no? So one order can buy multiple products. One product can be purchased in multiple orders. What is the relationship between orders and products? Many to many relationship. How to establish the many to many relationship? Create thought table. What is the thought table? Let's say order details. One field is then what same concept, same procedure is same. Take primary keys of both the tables. Take primary keys of both the tables. So take the primary key of this table into this table. So in this order details, what is order ID? Foreign key. Take primary key of products table. What is that is? Product ID. Next one, quantity. Next one, amount. How much quantity you purchased? Extra fields. Okay. Order ID 1000. You purchased product one, quantity one. Suppose some amount. In same order, customer is buying 101 also. He placed an order to buy product 100 and 101. So same one quantity. 1001, this is placed by different customer, different order. In different order, he is also buying product 100. He is also buying product 101. Possible or not possible? Possible. So this is placed by one customer. This is placed by different customer. Both are buying the same products, 100 and 101. So in this table, what is primary key? What is primary key? Can we take order ID as primary key? No. Can we take product ID as primary key? No. Then take what? Combination. Combination as primary key. Composite primary. Individual fields are foreign keys. Combination is what? Primary key. Order ID is one foreign key. That foreign key refer this primary key. Product ID is one foreign key. That foreign key refer this primary key. Combination is primary key. Understood? Then that's all. You try this example. You write create table script. Okay, na? Then what you have to write? So you write what's that? Write create table script. See, identify primary keys and foreign keys and write create table script. Okay. Similar example, previous student course. This is orders products. So both are relationship is many to many. Okay, then. Now, then just yet like 1 second. Then, but in the previous examples, okay. Uh, so combination of two fields uniquely identifies. The composite primary key contains how many fields? Two fields. Student ID, course ID, order ID, product ID. Okay, then sometimes not possible by using two columns. Then actually, why you go for two columns? Because it's not possible to uniquely identify by using single column. That's why you are going for combination of two. If not possible with combination of two, then If not possible with combination of two columns, then take combination of three. Not possible with three, combination of four, like that. Maximum we can go up to 32. Maximum we can go up to what? 32 columns. Composite primary key can contain maximum how many columns? 32 columns. Okay, then. So composite primary key can contain maximum 32 columns. Now, now, suppose there is a table, sales table. Just listen. There is a table, sales table. In sales table, every company doing the sales business, Amazon, Flipkart, everyone maintain this table. Okay, na? Then one field is date ID. One field is okay. One field is product ID. One field is customer ID. One field is quantity. One field is amount. Date ID, product ID, customer ID, quantity, amount. What is this is which day, which product sold to which customer, what the quantity sold, what the amount. Which day, which product sold to which customer, what the quantity sold, what the amount sold, what the amount. So date ID, you take yesterday, that is what 25th April 24. Product 100 sold to customer 10, quantity amount 2000. Yesterday, product 100 is sold to customer 10. And yesterday, suppose product 101 sold to customer 1. Possible or not? Yes. Yesterday, he purchased two products, 100 and 101. Yesterday, suppose 25th April 24, product 100 is sold to customer 1. Product 100 is sold to customer 11. Possible or not? So this is sold to different customer. Customer 10 purchased 100, customer 11 also purchased 100. Next day, 26, today, 26 April, product 100 sold to customer 1. Possible or not? Today also he purchased. Yesterday he purchased this product. Today also he purchased this product. Now this table is given to you. They ask identify primary key in this table. Then tell me what. This table is given to you. Identify primary key in this table. Can we take date ID as primary key? No. Product ID? No. Customer ID? No. Quantity? No. Amount? No. Then can we take this combination? Can we take this combination? Date ID, product ID? Huh? Can we take this combination? Date ID, product ID? No. Can we take this combination? Date ID, product ID? No. Why? Because this combination is also repeated. 25th 100, 25th 100. This combination is also repeated. Product ID, customer ID combination? No. 110, 110. This combination is also repeated. You cannot take this combination. Then, so take combination of three. Take combination of what, sir? Three. Three fields. So date ID, comma product ID, comma customer ID. That's all. Here, previous one, two. Previous example, 2 is enough. But in this example, what, sir? 3. When not possible with 1, 2. Not possible with 2, 3. Not possible with 3, 4. Like that. So then what? In this example also, identify primary key and write what, sir? Create table script. Then so you try these two examples. This one, this one. Create this. Right? What you have to write? You have to write create table scripts. Okay, now then next. Okay. Then now let's see. Next one. See this here. What? Composite foreign key. There is one more. That is what? Composite foreign key. Composite primary key is there, na? Like that composite foreign key. What is composite foreign key? If foreign key, what? Declared for, if foreign key declared for combination of columns, then it is called what? Composite foreign key. If foreign key declared for combination, then it is called composite foreign key. If primary key is declared for combination, composite primary key. Similarly, if foreign key is declared for combination, composite foreign key. Okay, then next one. Then next. Next one. If composite foreign key, a composite foreign key refers composite primary key. A composite foreign key refers composite primary key. If foreign key is composite, the primary key must also be composite. Actually, what is the rule? Foreign key refers primary key, na? If foreign key is composite, primary key must also be composite. Example, let's say example, then example, like you take 1 second. What is this table is? Registration, student course registration. This is the table, registrations table. Just listen. This is the table. In this table, what is primary key? Combination is primary key. Yes. Next. Student completes course. When completing course, what is issued to the student is certificates. A certificate is issued to the student. In this one field is certificate number, date of issue. In this one field is certificate number, date of issue. What is the primary key? Certificate number. Certificate number. How certificates are uniquely identified? Certificate number. So then certificate number is what? Certificate number is 100. Date of issue so and so date. Is this two fields enough? Huh? If this is enough? If this is enough? No. Then like why? Because if I ask this certificate issued to which student, you cannot answer. This certificate, see, you store the data in such a way that in tables, you store the data in such a way that it should answer to the questions. It should give the details. Without, if it is not giving the details, no use of storing the data. Yes or no? Then I'll ask this certificate issued to the which student. Then what should be there? Student ID should be there. Student ID is what, sir? 1. Now you can answer this certificate issued to which student means student 1. Again, the problem is I'll ask this certificate is issued to which student by completing which course. The certificate is issued to the student, na? But I'll ask by completing which course this certificate is issued to the student. Then what should be there? Course ID should be there. Course ID is 10. Course ID is 10. Now the complete details are there. Student 1 completed course 10. By completing this course 10, a certificate is issued to the student. So and so date. Sir, yes or no? Then, so student 1 completed course 10. By completing this course 10, a certificate is issued to the student. 101, so and so date. Next one, student 1, 11. What is the meaning? Student 1 completed course 11. By completing this course 11, a certificate is issued to the student, so and so date. Next one, 102, 102, so and so date. Suppose student 2, course 11. What is the meaning? Student 2 completed course 11. By completing this course 11, a certificate is issued to the student. Yes. But tell me, this is valid or invalid? This is valid or invalid? Invalid. Why? Because the student who completed course 10 is not completed course 11. When is not completed course 11, how can you issue the certificate? What this table is telling that which student completed which course? Student who completed course 10. Okay. So is not completed course 11. When is not completed course 11, how can you issue this certificate? This is invalid or not? Yes. And now what is the rule here? This combination should match with this combination. This combination should match with this combination. 110. 110 is matching or not? Yes. 111 is matching or not? Yes. 211 is matching? No, not matching. So what is this is? This is what, sir? Invalid. So this combination should match with this combination. That means this combination must be declared. See, sir, no confusion because simple concept is simple. A column value should match with another table primary key. Then that should be declared as foreign key. A column value should match with another table primary key. So this combination should match with this primary key. This combination must be declared foreign key. Here foreign key is for single column combination. Combination. Then it is called composite primary key. That's all. Sorry, composite foreign key. Okay. Then. So in the above example, SID CID combination should match with registrations table SID CID combination. So declare this combination as what? Foreign key at table level. Okay, that's all. So right? Create table. Registration table is already created. Create what? Certificates table. Then how? Create table what? Create table what? Certificates. One field is certificate number. This is number 4. What is this is primary key. Date of issue, date, SID, number 2, student ID. What is student ID? Student ID. Student ID is one foreign key, na? Student ID is foreign key. No, student ID is not foreign key. Student ID, course ID combination is foreign. Okay, na? Individual columns are not foreign keys. What is foreign key? Combination. Student ID. Any consent is there for student ID? No. Any consent is there for course ID? No. No consent. Student ID. Any consent is there for student ID? No. Any consent is there for course ID? No. Then in this table, what is there? Foreign key is there. Combination is foreign key. Then declare this combination as foreign key at table level. Then how? How to declare? You have to mention like this. Foreign key, brackets. Which combination? SID, CID. SID, CID combination is what? Foreign key. SID, CID combination is foreign key. Okay. And this foreign key, when foreign key is there, compulsory what must be there? References must be there. This foreign key refers which table? Primary key. When foreign key is there, compulsory references must be there. Na? Then references, which table? Not both the tables. So this foreign key refers what? Registration table primary key. This foreign key must match with this primary key. Yes or no? This foreign key refers this registration table primary key. References, which table? Registration table. Which column? SID, CID. That's all. Now a relationship is created between the certificates table and registration table. A relationship is established between certificates and registration. In this relationship, certificates is what? Child table. Registration is what? Parent table. Primary key table is always parent. Foreign key table is always child. Now create the table. So what this is called? Composite foreign key, because you are declaring foreign key for combination. Okay. Then okay. Now create this table. Okay. References. Okay, na? References. Then create this table. So table is created. Now you want to test, insert this row. I don't insert all the rows, just insert, just for testing. Okay, then. So in registration table, select start from what? Registrations. This is the registration table. So in certificates table, enter combination which is not there in the registration. So 110 is there, 111 is there, 210 is there. Try to insert a combination which is not there in registrations table. How? Insert into what? Certificates. Insert into certificates values. Certificate number 1000. Date of issue, sysdate. SID, student 1. SID, student 1. Course ID, what's it? Student 2. SID, student 2. Course ID is 11. But this combination is there or not there? Not there. So that means actually is not registered for course 11. When it's not registered for course 11, you cannot issue the certificate. Yes or no? Let's execute this command. What this command gives? This command gives what? Error. What this command gives? This command gives error. Integrity constraint is violated. Parent key not found. Integrity constraint is violated. Parent key not found. That means this foreign key is not matching with what? Primary key. Okay. So what this command gives? This command gives what's that? Error. Okay. That. Okay. Then that's it. So this is what is this is this is what. So declaring constraints at column level and table level. You learn both methods. Okay. Then. So a question is which of the following constraint cannot be declared at table level? Which constraint cannot be declared at table level? A, suppose, okay, na? Then unique. B, check. C, not null. D, primary key. E, foreign key. Okay. Which of the following constraint cannot be declared at table level? Then, what? Which constraint? Check. Let's go to our first example, table level. We started table level. So this is declaring check consent at table level. Our first example is check consent only. Then next, what? Sir, here you can rule out easily. Three you can rule out. What? Check, we have seen example. I give an example for check. I give an example for primary key. I give an example for foreign key. Just now we have seen this is foreign key. So answer is there between only two. What are the two? Unique and not null. When primary key is possible, unique also possible. When primary key is possible, unique also possible. Answer is not null. Not null cannot be declared at table level. Not null is always declared at column level. All constraints can be declared at table level except not null. Because you can't declare not null for combination. Not null is declared for single column. Not null cannot be declared for combination. Not null constraint cannot be declared for combination. Not null is declared only for single column. So that's why you cannot declare at table level. Okay. So unique can be declared at table level. Primary key can be declared. Foreign key can be declared. Check can be declared. Only not null cannot be declared at table level because not null cannot be declared for combination. Not null is always declared for single column. Okay. Then understood. Then okay. 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 Here you tell me, suppose, for example, there is one question. What is that is then? Okay, then once again. So this is D. Okay. So what is the question? Which statements are true regarding constraints? Which statements are true regarding constraint? A foreign key cannot contain null value. You have to say true or false. That's all. A foreign key cannot contain null value. False. Foreign key allows null value. Foreign key allows duplicates. Foreign key allows null values. But it is saying cannot contain, but it can contain. This statement is true or false? False. A column with unique constraint can contain null value. A column with unique constraint can contain null value. Yes, this is true. This is false. A constraint is enforced only for the insert. Constraint is enforced only for the insert operation. Means what the meaning is, Oracle check the constraint only at the time of insert, not at the time of update delete. That is the meaning. No, Oracle also checks at the time of update. Can you update the primary key value to the duplicate? No. Oracle also checks at the time of update also. Then this is true or false? False. All constraints can be defined at column level and table level. All constraints can be defined at column level and table level. False. Because not null cannot be declared at table level. That's all. So what is the which statements are true regarding constraint? A foreign key cannot contain null value. No, foreign key allows null value. This is false. A column with unique constraint can contain null value. Yes, unique allows nulls. A constraint is enforced only for the insert. No, not only for the insert, it also enforced for the update also. False. All constraints can be defined at column level and table level. False. Because not null cannot be declared at what, sir? Table level. Okay, then. Okay, then. Now let's see that. So in this every topic, there are some questions are there. Okay, then. So let's see. What is asking is which create table statement is valid? Which create table statement is valid? First one, valida, invalida? Invalid. Why? Two primary keys. Table allows only one primary. This is invalid. It gives error. You test it, like run this. Okay, now then you test and check whether it will allow or not. Table can have only one primary key. Second one, B, valida, invalida. Invalid. Why? Hmm? Everything you have to observe. It is everything you have to observe. Okay, now then B. B. This is valid or invalid? Huh? Invalid. Why? Sir, here, that's what I'm saying. Everything you have to observe. Comma also matters. Here, you declare two constraints, no problem. You can declare two, but they should not separate by space. Sorry, they should not separate it by comma. They should be separated by space. But it is separated by comma. Then it is not valid. You can declare multiple constraints. You can declare two constraints, but should be separated by space, not by comma. So they are separated by comma. Invalid identifier. You see that it is giving like this. What it is considering, not null is a separate column. Here you given comma, na? If you give comma means this column is completed. You are starting second column, but second column name is not null. So column name is not null. That's why it is saying invalid identifier. Name identifier means name. Table name, column names are called identifiers. So identifier name is starting with not null. Yes or no? Then next, third one, third one, third one, valida, invalida. Hmm? That's all. Here, actually, then to answer these two questions, compulsory you should have like practice. Then only can able to answer. Uh, then what? Valida, invalida. Huh? Valida, invalida. Invalid. Why? Hmm? What is the problem here? The problem is default. When you declare default, compulsory should declare a value. Default should be declared with a value. We have seen example, default, hide date, date, default, sys date. When you declare a default, compulsory you have to declare what? Value. But is declaring default, but is not declaring the value. Value is missing. Then what this gives? Error. What is the reason? Default is not declared with a value. Default is not declared with a value. Then this gives what, sir? Error. What is it saying? Missing expression. After default, expression is missing. Value is missing. Default should be declared with a value, but you are not declaring value. Then next one. D. D. Alloda, not alloda. Sorry, valida, invalida. D. Order number, item number, order date, date, default. This is date. Now default is declared with a value or not? Yes. Next one, not null. Primary key, order number, comma, item number. What is this is? What is this primary keys? Composite primary key. Like we are taking order number, product number, na? Instead of product is taken what? Item number. Okay. Then this is what? Primary key. Composite primary key. Then this is valid or not? Yes, valid. So let me run this command. Suppose execute this command. Table is created. Understood that? Sir, why first one is invalid? Two primary keys. Two primary keys. Why second one is invalid? Constraints are separated by comma. Why third one is invalid? Default is not declared with a value. Fourth one is valid. That's understood that. Next. once again, suppose here, then. Sir, let's see, then. Let's see this. See, once again, he has given a table. What is the table? Order table. What are the fields? Order ID, customer ID, order date, order amount. Order ID, customer ID, order date, order amount. Okay. Then you inserted some rows into the table. After some time, you want to alter the table by creating the primary key constraint on the order ID. Okay. So this is related to the next topic. This question is related to the next topic. Okay. Then, okay. First, we'll see that. Then, because you don't know that. Then, sir, in all these examples, you declared the constraints. You declared the constraints at the time of creating the table. Yes or no? While creating the table, you declared primary key, foreign keys like that. But table is already there. I want to add constraints to the existing table. I want to add constraints to the existing table, not the new table. So table is already there. After creating the table, I want to add constraints. Okay, alter. So suppose, for example, one company started, they are storing employees' data. In the beginning, there is no rule. After some years, they want to declare a rule, minimum salary should be 5,000. They want to declare a rule, minimum salary should be 5,000. Then what? Table is already there, data is already there, but they want to add a rule, minimum salary should be 5,000. Then what? Add constraint. Yes or no? Okay, na? Understood? Add constraint. Between the two tables, there is no relationship. I want to establish the relationship after creating the tables. The tables are already there. I want to establish the relationship after creating the tables. Then add foreign key. Add foreign key. Okay. Then now let's see how to adding constraints to what? Existing table. Not the new table. Adding constraints to existing table. Okay. Then. So can you guess what command we use? What command? Alter. Alter command is used to add constraints to existing table. So after creating the table, alter command. So alter command is used to add constraints to existing table. Okay, then what? First, I'm creating a table. Create table MP66. One field is MP number 4. One field is ename varchar 210. One field is salary number 7. One field is what? One field is salary. One field is DNO number 2. One field is email ID varchar 210. Then so I'm creating the table without what? Constraints. No constraint. Okay. After creating the table, I'll add, because you should know both how to declare the constraint at the time of creating, after creating, how to add the constraints to the existing table. You should know both. Okay, then so create the table. Then okay, now then employee number, name, salary, DNO, email ID like this. Then okay, then so this is what creating what's a table, creating the tables. Okay, then next. So after creating the table, now let's see what's that adding. What adding what primary key? Adding primary. I want to add primary key. I want to add primary key. Add primary key to EMP. Add primary key to EMP. I want to add primary key to employee number. We are adding primary key after creating the table. What is the command? Alter table. Which table? EMP66. Add. You want to add now? Add. What do you want to add? Primary key. Bracket. Which column? EMP. Add primary key to this EMP. Yes or no? Then. So alter table EMP66. Add primary key EMP. After executing this command, primary key is added to EMP. After executing this command, the primary key is added to EMP. Okay. Then. So we are adding primary key after creating the table. So table is already there. Drop the table, create the table. First create the table. Create the table. So table is created. After creating the table, then execute this command. Execute this command. Okay. Then. So table is altered or not? Yes. Primary key is added to this EMP. So this is the, see, this is the table EMP66. In this field is what? EMP. EMP contains values 100, 101, 100, 101, null, next one, null, next one, null, like this. The table is already there, column is already there, values are already there. I want to add primary key. Can you add primary key to EMP? Can we add primary key to this EMP? Can we add primary key to this EMP? No. Why? Because it's already contains duplicates, because it contains duplicates and null values. You cannot add primary key to the column that already contains duplicates. So adding primary key after creating the table means it does not mean that it will allow the duplicates and nulls. No. Okay, no. Then this column, you cannot add primary key to this because it contains duplicates and null values. If you want to add primary key, first what you have to do, remove the duplicates, remove the null values, then add primary key. Remove the null values, remove the duplicate, then add primary key. Understood? That's it. Okay. That. So this is how to add what? How to add primary key after creating the table. Okay. Then. So next we'll see like what? Adding check, adding foreign key, adding unique, adding not null. We'll see that other constraints. So in constraints, two topics are left. This one, this is one, another one, delete rules. One, this is completed, delete rules. One, this is completed, constraints topic is completed, then we can start next topic. Okay. So this is adding and dropping, adding the constraint, dropping the constraint. After that, one topic is there, delete rules. Then once it is completed, then we can start another topic. Okay, then okay. So we'll continue this tomorrow. Okay then. Okay. Okay then.